Hello children, welcome to e-learning. Hope you all are doing good. I wish to see you all geared up for another interesting session of mathematics. Today's topic is very closely associated to our daily life. I am sure you all will be amazed to see how familiar you are with this topic, even though you are not acquainted with it, but you have been using the applications of the concepts. So, before we actually go into it, let us look at the scenario. On a Sunday, Ramesh and Suresh planned to visit Birla Temple. Using Google Maps, Ramesh and Suresh started heading to Birla Temple from their respective residences. Suresh started on his bike from his home and checked the distance on Google Maps. It showed him 6 minutes time would take and it was 2 kilometers away from his home. Ramesh waited at the bus stop but then thought to go by cab. So, he booked one and he could see that the cab would arrive in another 5 minutes. Also, both of them understood where exactly the other person was there and how much time it would take for them to reach. But how were they able to know this? Yes, you guessed it right, using GPS, that is Global Positioning System. And how was this possible? Google Maps knows your position via the Global Positioning System, and for this coordinate geometry is used. Now, what is coordinate geometry? Coordinate geometry is a branch of geometry where the position of the 2 points on the plane is defined with the help of an ordered pair of numbers, also known as coordinates. Using coordinate geometry, it is possible to find the distance between 2 points, dividing the line in m:n ratio, finding the midpoint of a line, calculating the area of a triangle in the Cartesian plane, etc. So, let us see how coordinate geometry works in real space. Children, in this digital world, we are all able to send enormous data from one corner of the world to another place in a jiffy. Did you ever think how are you able to do it? I will tell you how. Any text file or PDF file are written or modified with the use of coordinate geometry. The file containing the text, images and different shapes are placed according to the two-dimensional coordinate XY system. Look at the images, children. I am sure you must have recognized them. Yes, they are scanner and photocopying machine. Scanner and photocopying machine also use coordinate geometry to produce the exact image of the original image provided to it. When you look at this image, children, are you able to identify what is it about? Yeah, it is air traffic. So, location of air transport, all the air traffic is controlled by air traffic controller. A controller must know the location of every aircraft at any particular instant of time in the sky. Coordinates of any particular vehicle are used to describe its current location of the aircraft. Children, I am sure you all enjoy locating different places, countries, cities on the maps on your computer screens. Have you ever wondered how a 3D object like Earth is being represented as a 2D flat surface on your computer screen? Yes, this is possible because of the map projections. It is a technique to map any 3D curved object on a flat 2D surface. If we have to represent Earth on a flat map, this technique can be used, and for this coordinate system is used called as projected coordinate system. These are mainly used to represent the maps on computer screens. I am sure children you all have identified the image there. You are very familiar with it in your social studies class. They are latitudes and longitudes. For the real world locations, describing the accurate location and shape of features will require a coordinate framework. So, for this a special coordinate system called geographical coordinate system is used to assign geographic locations to objects. Yes children, so we have seen how coordinate geometry is related to our daily life and facilitating our living without we even realizing it. Now, let us get into the learning. Children, let us quickly revisit our knowledge about coordinate plane and its contents. A coordinate plane is a two-dimensional plane formed by the intersection of a vertical line called y-axis and a horizontal line called x-axis. These are perpendicular lines that intersect each other at 0, and this point is called as origin. Now, this pair of perpendicular lines divides the coordinate plane into 4 quadrants: Q1, Q2, Q3 and Q4. In Q1, we observe that the ordered pair has the coordinates both positive. In Q2, we have the coordinates to be minus x and plus y, that is negative x value and positive y value. Coming to Q3, the x coordinate and y coordinate, both of them are negative. And when we come to 4th quadrant, it is positive x and negative y. Why is this so, children? Because if you observe, Q1 is made up of positive x axis and positive y axis. When we observe Q2, it is made up of negative x axis and positive y axis. That is why we find negative x value and positive y value. When we come to Q3, we have negative x and negative y. That is why our ordered pair consists of coordinates both negative. Coming to Q4, we have positive x and negative y. So, we have positive x value and negative y value. Children, both the coordinates are positive and x coordinate is called as abscissa. What is it called, children? It is called as abscissa. And y coordinate is called as ordinate. We call y coordinate as ordinate. So, we can have a point in Q1 like 5 and 4. Similarly, coming to Q2, we can have a point like minus 3 and 5. And in Q3, we have minus 4 and minus 5. And in Q4, we can have plus 3 and minus 6. Let us learn how to find the distance between 2 points in the coordinate plane. For that, let us get ready with our coordinate plane. Let us draw the x-axis, x and x dash, y and y dash, and the intersecting point would be the origin. Let us consider 2 points A x1 y1 and B x2 y2. If you observe, children, the y coordinates in both the points are same. Since y coordinates are equal, points lie on a line parallel to x-axis. So, we will be drawing 2 perpendiculars from A and B respectively. So, AP and BQ are drawn perpendicular to x-axis. When you observe APQB, it represents a rectangle. So, APQB is a rectangle. Therefore, AB will be equal to PQ, since opposite sides of a rectangle are equal. But PQ is equal to x2 minus x1, which implies AB also is equal to modulus of x2 minus x1. Why are we writing modulus, children? Because we will be considering only the absolute value of the difference. Similarly, line joining 2 points A x1 y1 and B x1 y2 is parallel to y axis. Then AB would be equal to modulus of y2 minus y1. Now, let us learn how to find the distance between 2 points in the xy plane. So, let us first draw x axis, y axis and the intersecting point origin. Let A x1 y1 and B x2 y2 be 2 points, any 2 points in the xy plane. Draw AP and BQ perpendiculars to x axis, just like how we did in the previous case. Now, what are we doing, children? We are drawing a perpendicular from A on BQ. So, AR is perpendicular to BQ. Then OP is equal to x1 and OQ is equal to x2. Draw a perpendicular AR from the point A on BQ. Then OP is equal to x1, OQ is equal to x2. So, PQ is equal to OQ minus OP, which is equal to x2 minus x1. Now, observe the shape of APQR. It is a rectangle. So, PQ is equal to AR, which is also equal to x2 minus x1. Also, QB is equal to y2 and QR is equal to y1. So, BR is equal to QB minus QR. So, that comes out to be y2 minus y1. In the triangle ARB, which is a right angled triangle, AB square is equal to AR square plus RB square. Children, please observe, we have used Pythagoras theorem over here. So, AB square is equal to x2 minus x1 whole square plus y2 minus y1 whole square. So, AB is equal to under root x2 minus x1 whole square plus y2 minus y1 whole square. Hence, D, the distance between the points A and B is equal to under root x2 minus x1 whole square plus y2 minus y1 whole square. This is called the distance formula. Please understand, children, this is a very important formula to be used whenever you have to find the distance between 2 points in the xy plane. Let us take an example of it. Find the distance between 2 points A 4,3 and B 8,6. We are given 2 points A 4,3 and B 8,6. So, first let us compare the points A and B with x1 y1 and x2 y2. So, when we compare, children, we get x1 as 4, y1 as 3, x2 as 8 and y2 as 6. Using distance formula, which is under root x2 minus x1 whole square plus y2 minus y1 whole square, we get AB is equal to under root 8 minus 4 whole square plus 6 minus 3 whole square, and that comes out to be under root 4 square plus 3 square, that is equal to under root 16 plus 9, which is root 25, and it is equal to 5 units. Let us consider another example, children. Show that the points A 4,2, B 7,5 and C 9,7 are 3 points lying on a same line. Did you understand the question, children? He is asking us to show that the given 3 points are lying on the same line. For that, we will be using the distance formula. Let us find the distances AB, BC and AC by using distance formula. For that, first let us draw the figure appropriate to it. ABC are given to us and we have to show them lying on the same line. And we know that the distance formula is under root x2 minus x1 whole square plus y2 minus y1 whole square. So, AB comes out to be under root 7 minus 4 whole square plus 5 minus 2 whole square, which is equal to under root 3 square plus 3 square, because we are considering only the coordinates of A and B. So, we will be taking x1, y1, x2, y2 from only A and B, children. So, what do we get? We get under root 9 plus 9, which is equal to under root 18, and that comes out to be 3 under root 2 units. So, we got AB as 3 root 2 units. Similarly, we will find out BC, and BC comes out to be under root 9 minus 7 whole square plus 7 minus 5 whole square, which is equal to under root 2 square plus 2 square. That gives me under root 4 plus 4, which is equal to root 8, which is equal to 2 root 2 units. So, we got BC as 2 root 2 units. Now, when we find CA, we get under root 9 minus 4 whole square plus 7 minus 2 whole square, that gives me under root 5 square plus 5 square. So, we get under root 25 plus 25, that is root 50, and 5 root 2 units. So, when we add up AB and BC, we are getting 3 root 2 plus 2 root 2, which gives me 5 root 2, and that is equal to AC. So, we are able to get AB plus BC is equal to AC. So, we are able to prove that the points A, B, C are on a straight line, and these 3 points are collinear points. Now, let us consider another example. Children, show that the following points form an equilateral triangle: A, A, 0, B, minus A, 0 and C, 0, A root 3. So, let us find the lengths of the sides of the given triangle using distance formula. Because we are given coordinates, children, first let us find the distance formed by these 3 coordinates to show whether it is an equilateral triangle or not. Remember children, we can prove any triangle as equilateral only if all the sides of a triangle are equal. So, for that let us find the sides first. So, AB is equal to under root minus a whole square plus 0 minus 0 whole square. That gives me under root minus 2a whole square, that is equal to under root 4a square, which is equal to 2a. BC is equal to under root 0 minus of minus a whole square plus a root 3 minus 0 whole square, that is equal to under root a square plus 3a square, that gives me under root 4a square, which is equal to 2a again. Now, when I find CA, CA is equal to under roots a minus 0 whole square plus 0 minus a root 3 whole square, that gives me under root a square plus 3a square, which is equal to under root 4a square, which comes out to be 2a again. So, we could get AB is equal to BC, which is equal to CA, and all the 3 sides we got it as 2a. As we find all the 3 sides equal, the given triangle is an equilateral triangle. Children, the same concept can be used if you are asked to prove any triangle as isosceles triangle or right angled triangle using the distance formula and the respective application. Now, let us look at another example. Show that the points minus 4, minus 7, minus 1, 2, 8, 5 and 5 minus 4 taken in order are the vertices of a rhombus. Find its area. So, let the points be A minus 4, 7, B minus 1, 2, C 8, 5 and D 5 and minus 4. Let us draw the relevant figure to it. To prove ABCD is a rhombus, we have to prove all the sides are equal and diagonals are not equal. To prove ABCD as a rhombus, first we have to prove all the 4 sides are equal and the diagonals are not equal. When we compare this to a square, in square also we have all the 4 sides equal, but the diagonals are also equal in a square, whereas in rhombus all the 4 sides are equal, but the diagonals are not equal. Find the sides of it. So, AB is equal to under root minus 1 plus 4 whole square plus 2 plus 7 whole square, that gives me under root 9 plus 81, which is under root 90, and I get 3 root 10 as AB. Similarly, when I find BC, I get under root 8 plus 1 whole square plus 5 minus 2 whole square, that gives me again under root 81 plus 9, that gives me again under root 90, which is 3 root 10. Now, coming to CD, I get under root 5 minus 8 whole square plus minus 4 minus 5 whole square, that gives me under root 9 plus 81, which is equal to under root 90, which is 3 root 10 again. And finally, DA is whole square plus minus 4 plus 7 whole square, which is equal to under root 9 square plus 3 square, which is equal to under root 81 plus 9, and that gives me under root 90, which is 3 root 10 again. So, when you observe children, we could get all the 4 sides as 3 root 10, which means we have found out that all the 4 sides are equal. So, we proved that all the 4 sides of the ABCD are equal. Now, let us find the diagonals AC and BD. So, AC is equal to under root 8 minus of minus 4 whole square plus 5 minus of minus 7 whole square. That gives me under root 144 plus 144, which is under root 288, and I get 2 under root 72. And BD is equal to under root 5 minus of minus 1 whole square plus minus 4 minus 2 whole square, that is equal to under root 6 square plus minus 6 whole square, that gives me again under root 72. If you observe children, AC and BD are not equal. AC we got it as 2 root 72 and BD as under root 72. So, AC and BD are not equal. So, now let us find the area. For the area of rhombus, which is equal to half of the product of its diagonals. I repeat the formula children, if you want to find the area of rhombus, you have to find the product of diagonals and find half of it. So, half of 2 root 72 into under root 72, 2 and 2 when they get cancelled, I am left with only under root 72 whole square, that is equal to 72 square units. Let's move ahead to another example. Find the point on the x axis which is equidistant from 2, -5 and -2, 9. For this, let the points be A 2, -5 and B -2, 9, and let P be the required point which is equidistant from A and B on the x axis, and the coordinates of P would be A and 0. So, let us draw the figure relevant to it. We are marking the points A and B, and let our point P be A, 0. What is given to us? It is given that AP is equal to BP. So, under root A minus 2 whole square plus 5 square is equal to under root A plus 2 whole square plus 9 square. When I square on both sides, we can actually be able to remove the square roots, children. So, squaring on both sides gives us A square minus 4A plus 4 plus 25 is equal to A square plus 4A plus 4 plus 81. Cancel A square on both sides. We are left with minus 8A plus 29, which is equal to 85. So, when I transpose the constant 29 to the other side, I get minus 8A is equal to 56, and which implies A is equal to 56 by minus 8, which is equal to minus 7. So, my required point P is minus 7, 0. Okay, children, we will move on to the next example. If the distance between two points x7 and 115 is 10, find the value of x. What is given to us? We are given 2 points and also the distance between them, but we are asked to find the missing coordinate. Okay. So, for that, first let the points be A x7 and B 1, 15. So, let us actually draw the relevant figure for that. But what is given to us? Given AB is equal to 10. So, the distance between A and B is equal to 10 units, which implies AB square is equal to 10 square, which is equal to 100. So, x minus 1 whole square plus 7 minus 15 whole square is equal to 100. So, x minus 1 whole square plus minus 8 whole square is equal to 100. So, I get x minus 1 whole square plus 64 is equal to 100, and I will be transposing this 64 to the other side, where I get x minus 1 whole square is equal to 100 minus 64, plus 64 when transposed to the other side gives me minus 64. So, x minus 1 whole square is equal to 36, which means to remove the square I have to apply the root on the other side. So, x minus 1 is equal to under root 36. So, x minus 1 will be equal to plus or minus 6. So, we take 1's plus 6, x minus 1 is equal to plus 6, which means x is equal to 6 plus 1 and x comes out to be 7. And the other case, x minus 1 is equal to minus 6. So, I get x is equal to minus 6 plus 1 and I get x is equal to minus 5. So, if you observe, children, we got two values for x, that is 7 and minus 5. Okay, children, I hope you all understood what is coordinate geometry, how to plot the points, how is it related to our daily life, and how to find the distance between 2 points in the xy plane. Let us take a quick recap of the concept what we have learned today. The distance between 2 points P x1 y1 and Q x2 y2 is under root x2 minus x1 whole square plus y2 minus y1 whole square. Second one, the distance of a point P x, y from the origin is under root x square plus y square. The distance between 2 points x1 y1 and x2 y2 on a line parallel to y axis is modulus of y2 minus y1. The distance between 2 points x1 y1 and x2 y2 on a line parallel to x axis is modulus of x2 minus x1. That is all for today, children. You can try your textbook problems based on the examples which we have learnt today. There are a few set of questions which you can try them. Check if the points 5 minus 2, 6, 4 and 7 minus 2 form an isosceles triangle. Prove that the points minus 7 minus 3, 5, 10, 15, 8 and 3 minus 5 taken in order are the corners of a parallelogram. Can you draw a triangle with the vertices 1, 5, 5, 8 and 13, 14 give reasons. And find a relation between x and y such that point x y is equidistant from the points -2, 8 and -3, -5. Okay children, I hope you all enjoyed today's class and I am sure you all understood what is coordinate geometry, how to plot the points in the xy plane and also how to find the distance between the 2 points. Also you all must have been surprised and amazed to know how coordinate geometry is closely related to us. See you all in the next session with a few more concepts related to coordinate geometry. Till then, happy learning.